Okay, welcome to part two of day two of trigonometry. We are going to focus in this video on how do I solve for an unknown angle measure as opposed to an unknown side length. So if you watched the other video, we were solving for unknown side lengths. If you didn't, it really doesn't matter what order you go in. That's the difference between the two. But that's why we're starting with problem 7 here. Before we get started, I'm going to introduce you to a new variable. We have a question mark in this picture, and clearly we don't usually use question marks in math. So we could call that x because it's my unknown. But I'm going to say, let's call it theta. And what I just wrote there, rather small, is basically a 0 or a capital letter O, with a sort of a squiggle line across it, and that we pronounce as theta. It's a Greek letter, and that's a common choice for an unknown angle measure in math. You'll see that in pre-calculus and all of your upper level math courses. So I'm just going to have you get used to it right now. If you're totally freaked out by theta, then just put an x right there, and every time I write theta, write x. It's the same thing. Okay? Just rewriting my trig ratios here because I have a feeling I'm going to need those. And I'm going to start this problem by labeling my triangle. So remember in the other video, we did label from my angle measure that I know. In this case, I'm going from the angle measure I don't know, but I'm seeking. So from that angle measure, oops, not going to let me undo it. I'm going to say that the 35 is my opposite, and the 45 is my hypotenuse of my triangle. So if I'm looking at opposite and hypotenuse, we should be looking at our first trig ratio, sine, and we're going to make an equation just like we did with the others. The only thing is that my variable is going to be in a different spot. So I start with my trig function, sine of, recall that after the sine, we put our angle measure. Well, in this case, we don't know our angle measure, so it's going to become sine of theta, or your x, if you put x there, is equal to, sine is my opposite over hypotenuse, so I'm putting in place of opposite 35, and in place of hypotenuse 45, since that's what I have. Okay, now I told you that after you write the equation, you're really done with the geometry part. So let's get rid of that and let's focus on this equation. Again, my unknown is my variable right here, and I'm asking myself the question, how do I solve for my unknown? That's always what I'm trying to do when I'm solving an equation. And I'm guessing that your first thought, common answer, is we say, okay, let's divide by sine. So I would encourage you to just go to your calculator for a second. And again, I can't show my calculator here, but just hit the button sine and hit enter. It should be giving you an error, a syntax error. What you just asked the calculator to do is the equivalent of taking the square root of nothing. Sine is a function, and you have to perform a function or an operation on something, some number or some variable. So we don't have the ability to do that. The calculator doesn't know how to read that. So we have to think inverse operations right here. Inverse operation of multiplying is divide. Inverse operation of taking the square root is squaring something. Inverse operation of taking the sine of something is what we call sine inverse, and we write that with a -1 exponent. So I'm actually going to take the sine inverse of both sides, and I know this is going to look weird, but here's what happens. On the left-hand side, the sine inverse and sine cancel each other out, and we're left with theta, my unknown that I'm seeking, is equal to sine inverse of 35 over 45. You're asking your calculator reads that as, instead of what's the ratio for a given angle, as we were doing in the other problems, if I write sine of a number, I'm asking the calculator what's the ratio between two sides for a given triangle. We're asking the calculator by this, what is the angle measure that has 35 over 45 as the ratio of the opposite and hypotenuse sides? And that's really what our picture is showing. Okay. So we go to our calculator. Make sure you're in degree mode. So if you need to check your mode, we're still talking to our calculator in degrees. We want an answer in degrees. And I'm going to go ahead. Notice that above the sine, cosine, and tangent buttons, you should see the sine inverse, cosine inverse, and tangent inverse with that -1 exponent. So hit the second function button, sine inverse. Should look exactly like this on your calculator. And then do 35 divided by 45. Your calculator is sometimes picky with fractions here, so I would just enter this as a division problem because that really is a division problem. And hit enter. And you should be getting 51.057, and it keeps going. I'm rounding to the 10th of a degree this time, so that would be this place. The 5 tells me to round up. So I'm actually going to get 51.1 degrees. Okay, just to show you, you might have been thinking, I know some of you were looking at this saying, well, 35 over 45, I really don't like that number. Let's divide by 5. And 35 over 45 is really 7 over 9. It absolutely is. So just try that for a second. Go ahead and do second sign 7 divided by 9. You should be getting the same answer. Okay, so not a problem if you wanted to simplify first. Remember, the angle measure should be the same because we're talking similar triangles here. What you really did is you just asked the calculator, what's the angle measure if my triangle looks like this, and I'm looking for a theta over here, but this side is 7 and this side is 9. And hopefully you can see that the triangle that I just drew and the triangle that we were given are similar triangles. So obviously that angle measure is going to have to be the same. Just for fun, if we wanted to get a radian measure, change your calculator mode to radian mode. Go back, type in the same thing. So second sign, either 7 over 9 or 35 divided by 45. And what you're getting is theta equals 0.891, and I'm going to stop there. I know I didn't round to the 10th place this time. Radians multiplied by pi. Multiplied by, we're going the other way this time, 180 divided by pi. And we're going to get back to this answer that we have right here. Okay, so I'm looking for answers in degrees. That's what we're going to be living in, is degree mode. I just wanted to show you that that does work out. Change your calculator back to degree mode, and let's go ahead and do a quick another example here. Okay, hopefully you set this one up in the following way. We're going to say from my angle that I don't know, which I'm going to call theta, this is my hypotenuse, and this is my adjacent side this time, so we're picking cosine, because I'm looking at the A and the H. My equation is going to read as cosine theta, unknown, is equal to adjacent over hypotenuse, 13 over 31. And same problem, I'm trying to solve for my unknown, but I've got a cosine there, so I'm going to do the inverse. And I get theta is equal to cosine inverse of 13 over 31. Type that in your calculator. Second cosine 13 divided by 31. And I'm getting theta is equal to 65.206. I'm going to round to 65.2 degrees. That's it, folks. These problems are all exactly the same, except for we're changing out trig function depending on which two sides we have. There is no different case. It's as simple as that every single time. So let's take a look at 4 more problems, just because I need to make sure you know how to do this. Go ahead and pause the video, draw those 4 triangles on your paper, and go ahead and solve those, and we will check in class.